Now we are going to see another important topic, that is your prism. So what is basically a prism? It is a transparent medium where the refraction takes place of a light. And do remember, there are two surfaces and the incident ray will emerge out of the surface, and do remember the light traveling through those two surfaces should be a plane and they should be non-parallel. So that's the standard definition of the prism. How does it looks like? That these are the two surfaces we were talking about. These are smooth and they are non-parallel, means they are intersecting at some point. So this is your white light which is incident through a prism, and it gets splitted into 7 colors. That is your Vibgyor, which is violet, indigo, blue, green, yellow, orange, red. The maximum deviation suffered by which light we can see here is your violet, and the least deviation suffered by the light is going to be your red, because the wavelength of red light is more, so its deviation is going to be less, right? So this is how prism works. Now we are going to understand an important derivation, that is deviation through a prism. Suppose this is an incident ray which is making an angle of I1, and now light will go straight. Now because of the phenomena called refraction, when a light is traveling from rarer to denser medium, it is going to bend towards the normal. So let's say this angle is R1. Now here we can see, let's say although this angle is R2 but I2, but we take it as R2. So this angle is your R2 and the emergent angle we are taking this one as I2. So once we see by an vertically opposite angle, I1 is equals to delta 1, this I1 and this delta 1 plus R1 is going to be equal. So what we are going to have from here as delta 1, and that comes out as I1 minus R1. Similarly, when we talk about I2 and delta 2 and R2, so again we can see this I2 and delta 2 minus delta 2 and R2, they are vertically opposite angles. So what we are going to have, we are going to have delta 2, and that is equals to your I2 minus of R2. Now this was actually incident ray and this is actually emergent ray. So this is basically the angle of deviation. So basically you have to find delta, and we can see that this delta is exterior angle to these two angles. So we have delta is equals to delta 1 plus of delta 2. So once we have delta equals to delta 1 plus delta 2, we can put these two values in this equation. So we are going to have delta as I1 plus I2 minus of R1 plus R2. So this is basically your deviation. Now we are going to apply the Snell's law. So how we are applying Snell's law? Let's say its refractive index is 1 and refractive index of the prism, let it be mu, and again it is going to air, so refractive index is going to be 1. So once we apply this, so we'll have 1 into sine I1, 1 into sine of I1, and that will be equals to what? Mu into sine of R1. So we have this. Now once we solve this further, so we have, when the angles are very small, this sine theta can be taken as theta. So we'll have I1 is equals to mu times of R1. And similarly, if we apply the Snell's law at this point, so we are going to have 1 into, not 1 exactly, it is going to be, because the refractive index inside is mu, so we'll have mu into sine of R2, and that is equals to 1 into sine of I2. Now again, when the angles are very small, so sine theta can be taken as theta. So we'll have I2 and that will be equals to mu times of R2. So we have the value of I1, we have the value of I2, that is mu R1 and mu R2. So once we put over here, so mu can be taken as common from it. So we'll have mu into R1 plus R2 and minus of what? R1 plus R2, right? So we'll have finally delta as R1 plus R2 common, and we are going to have mu minus of 1. So we'll write this as mu minus of 1. Now we got the relation for the deviation, but now what this R1 plus R2 can be written as? So we'll see to it further. So you can see this angle N and R1 and R2 is going to be your 180 degrees. So we have N plus R1 plus R2, and that is going to be equals to your 180 degree, right? And this angle A plus angle N is also going to be 180 degree, because these are the two normals. So this angle will be your 90 degree and this angle will be your 90 degree. So it's an quadrilateral. So opposite sum of all the angles of quadrilateral is 360. So sum of angle A plus angle N is also going to be your 180 degree. Now from these two equations we can conclude that angle A is going to be equals to R1 plus R2. Over here angle A is your angle of prism. So finally we get the formula for deviation, which is delta is equals to mu minus 1 into A. So we can write this delta as mu minus 1 times A. That's the formula for deviation through a prism. Now finally we got the output as delta as equals to mu minus 1 times A, that is your deviation through a prism. Now when we talk about deviation, that's the formula. Now we know that red light has the lesser refractive index as compared to violet light, so its deviation will also be going to be lesser. Now why this is happening? Because refractive index is inversely proportional to speed, and once we talk about speed, so speed is basically directly proportional to wavelength. So refractive index is inversely proportional to wavelength. Now if wavelength is more, then deviation is going to be less. So mu has to be directly proportional to S or delta, that is your deviation. So from here we can conclude the things that refractive index is going to be directly proportional to deviation. I hope you understood it. So we have another important condition, that is for minimum deviation, and it is observed that minimum deviation is only when I1 is equals to I2 is equals to I and R1 is equals to R2 is equals to R. Then we get the minimum deviation. So when we talk about its formula, so here the refracted ray inside the prism is going to be parallel to the base of prism. You can have a look at the diagram which we have seen earlier. So as we have taken the equation as R1 plus R2 and that was equivalent to A, now we have seen that minimum deviation condition is R1 is equals to R2 is equals to R. So we'll have R plus R, so we'll have 2R and that will be equals to A. So first of all we are going to get one condition, that is R is equals to A by 2. And now when we talk about another condition, so we know the formula for delta, that is what? Mu minus 1 into A. But how we got this formula? So earlier we have seen delta is equals to I1 plus I2, and I1 and I2 are equal. So I1 is I, I2 is I, and minus of it was what? R1 plus R2, which is in fact equivalent to A. So we can write this as A. Now that's the condition for minimum deviation. So from here we are going to get the value of I as delta min minimum deviation plus A and whole divided by 2. Now that's your I, and from here you have R, which is equals to A by 2. Now when you apply the Snell's law, so what is Snell's law? So it is going to be 1 into sine I, and I is basically your this, which is A plus delta min upon 2, and that is equals to mu into what? Sine R. And what is sine R? It is sine of A by 2. So from here we are going to get the prism formula, which is sine of A plus delta min upon 2 upon sine of A by 2. So that's your prism formula, and you can see the diagram that that's your minimum deviation, right? Which is, we have seen the formula where I is equals to I1 is equals to I2, which is equals to I, and this R1 is equals to R2 is equals to R. So that's the condition and that's the graph of it. So minimum deviation is basically where the angle of incidence is going to be this, there the light is suffering a minimum deviation, and we can calculate using that prism formula. I hope you understood it. Now we have the question based on this, where a light ray incident on a prism at an angle of 45 degrees. So we are given I, and that is equals to given us 45 degree, and the minimum deviation is obtained when the refractive index of the material is given as √2. So we are given basically mu is equals to √2, and we have to find the angle of prism. So what is the formula for that? So we have seen the formula, that is mu is equals to sine of A plus delta min upon 2 upon sine of A by 2. Right, now here we are given mu as what? √2. So we'll put the value of mu as √2, and we can take this incident angle as 45 degree. So we'll have √2. Now this was basically sin I upon sin r, and I is given as 45 degrees. So sin 45 is again what? √2, and we have multiplied it by what? Sine of A by 2. So once we solve this, so we'll have sine of A by 2, and that comes out as 1 by 2. Now what is 1 by 2? 1 by 2 is basically your sine of 30 degree. So 1 by 2 can be written as sine of 30 degree. Now sine will get cancelled out. So ultimately we are going to have A by 2, and that is equals to 30 degree. So what will be the value of A? A is going to be your 60 degree. So that's the option correct.